oh, I should just put Go routines everywhere. It'll be fine. There won't be any problems. And then you like try to debug the code 3 months later. And it's like, who wrote this and why did they do it this way? And you look and it's you and you're like, oh, oops.
Break out the old git blame and then you shut it down real quick when you see your name on there.
Yeah.
Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by DigitalOcean. DigitalOcean's developer cloud makes it simple to launch in the cloud and scale up as you grow. They have an intuitive control panel, predictable pricing, team accounts, worldwide availability with a 99.99 uptime SLA, and 24/7, 365 world-class support to back that up. DigitalOcean makes it easy to deploy, scale, store, secure, and monitor your cloud environments. Head to do.co/changelog to get started with a $100 credit. Again, do.co/changelog.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. Next week on Go Time, the tables are turned as our very own Matt Ryer gets interviewed. He's joined by his Pace.dev co-creator David Hernandez to answer tough questions by John and Johnny in a new mini-series we're calling Go in Production. Subscribe if you haven't, you might regret missing that one. Speaking of regrets, here we go.
So today we're going to be talking to you about regrets. Specifically, we're going to be talking about technical regrets. No need to go into how I broke my nose 2 weeks in a row. We'll talk about what caused these mistakes, how we learn from them, how teams and companies can sort of maximize the learning potential from whenever somebody on your team does make a mistake, and really just trying to show everybody that it's okay to make mistakes, that we all make them. Because I think that's something that we all need to understand going into tech, is that you are eventually going to mess up, and that's okay. It's more like what's more important is how you move forward. All right, so I guess to start with, does anybody want to talk about a time they made a mistake?
Well,
we're quiet.
Since it's crickets, I'll give it a shot. When I came to Go, I was really psyched about the concurrency. I came from Scala at the time, so I was doing actors and thread pools and all that. And it was, for me at least, it was super complicated, and I had to reread docs like every other day to figure out what was going on under the hood. So I came to Go, and I was like, yes, Go routines, channels, I got this. And then I immediately wrote actors in Go, which was just felt in retrospect like fitting a, square peg in a round hole, or the other way around. So definitely a mistake. I regret it because it cost me, I think, like a month after it was all said and done. But looking back, I think I learned a lot about like Go concurrency basics without, at the time, having really read through anything deep about concurrency in Go.
Yeah, I feel like everybody has the channels phase of Go, and whenever new people come with learning Go and how excited they are about that, I always I almost forget there's channels. I just don't use them that often. It's like, there's that thing that's really cool too. But yeah, I agree. There's definitely a lot of ways to go around that kind of that issue of concurrency, and just figuring out which one's appropriate at the right time. Stuff.
I've seen that a lot in so people go to learn like how to build web servers, and the first thing they'll ask is like, well, how do I use this concurrency? Because they're really excited about it, and I don't know if they're disappointed, but when they realize that it's already there and happening for them, they don't have to worry about it. I think some of them are just like, oh, well, I thought I was going to actually get to do something and use these things. It's like, no, you just kind of write regular code and just make sure it's thread safe and you're fine.
I guess over the time of going to new jobs, whenever I look at a code base, I can kind of gauge how familiar the person who wrote it is with Go, based on the number of channels and Go routines I see sprinkled throughout the code. I tend to see a ton of new people, and I definitely did it when I was first learning Go. That's just like, oh, I should just put Go routines everywhere. It'll be fine. There won't be any problems. And then you try to debug the code 3 months later, and it's like, who wrote this and why did they do it this way? And you look and it's you and you're like, oh, oops.
Break out the old git blame and then you shut it down real quick when you see your name on there.
Yeah.
I think that's okay, though, making those mistakes, I should say, because one of the mistakes I made when I first was jumping into Go was that I just felt like I overplanned, or I tried to like over-optimize for getting things perfect. So you'd read about how you shouldn't use MVC and you shouldn't do all these different things. And I sat down, I'm like, all right, I'm going to write this side project. It was a side project. It wasn't like my main work stuff. So I was like, I'm going to build this thing and it's going to be good Go code. And I think I spent so much time rewriting some stuff because I was like, oh, well, this is a bad way. And I realized why. And then I'd go back and rewrite it. And in the end, I'm pretty sure what I ended up doing was just using a simple MVC model and just got it done. And then later I was able to come back and tweak things and adjust. But I wasted so much time trying to like meet the expectations of everybody, I guess is how I'd put it. Mm-hmm. And to me, that was a big mistake because I feel like you learn more by just kind of jumping in and doing stuff rather than like trying to find the optimal path.
Yeah, I totally agree. I think that definitely early on, it's less important. I feel like once you start sharing code and libraries and stuff like that, there are a lot of those idiomatic things where, if you didn't do it at first, they might, require an API change in the future. You might have to change your versions to a new major version. Just it gets more complicated there. But yeah, at first, for sure, just jump in. Like all my code is like basically Ruby inside Go, first couple projects. So that was rough. And but yeah, you figure it out as you go for sure.
Yeah, and I find kind of over and over, I make a lot of the same mistakes in terms of kind of over designing. Most of the time I like to do it because it's fun. And then I turn around, I say, well, this could have been way simpler. I could have deleted this function or whatever. But I keep finding over and over that Go is a really forgiving language when you have to unsimplify or uncomplicated-ify. I hesitate to say simplify because it's really not making the code like semantically simpler. It's literally deleting syntax. Just really, really forgiving and allowing you to do that without changing large swaths of code outside of that area you're working with.
I also like to think about, I don't know if it was Corey Lanou or it might have been him that I was talking to, but he'd basically mentioned that when you're writing code, I think like getting something working is more challenging than refactoring something. So like just keeping that in mind and knowing that it's okay to make mistakes. And that's part of the reason we have like code reviews and peer reviews and all these other things in place is so that we can learn from each other and improve things, not because we expect people to have the perfect first version. I think that's a mistake a lot of people new to programming make is that they see code that, like somebody like Kris or Ben would have wrote, and they're like, oh, I need to write this the first time. And I'm like, they probably didn't even write it like that the first time. So like, I don't know why you're expecting yourself to do it.
I think that's an important point about like the difficulty of writing new code. I'm definitely experiencing that myself right now. I have like this new project at work and it's like, oh, write it from scratch. Like don't use anything else that anybody has, just like write a brand new thing. And I'm just like struggling to remember how to build all the stuff I'm used to just being there already. And that's like a really odd experience for me, but it makes me appreciate a lot the kind of coming into a code base and just being the person that gets to like quote unquote like fix it. Or like make it better or improve it.
Yeah, I'm working on a database project right now, and it's just in its infancy, but it's all just like some for loops over some basic data structures, and like it would just make any database engineer just cry, just how slow it would be. But I'll get there, get some tests around it, and yeah, it's so much easier once you have all that in place.
Yeah, I feel like if you go on GitHub and you look at some popular open source projects, I feel like that's sort of the Instagram of programming, in that you see the perfect result after everyone's put on the makeup and rolled camera and everything, and then we put that on ourselves. Whereas like Ben, you just said, you could just go in and write a for loop and it'll be good for a while. It's just you got to start somewhere.
Mm-hmm.
And there's always the telltale sign of like initial commit has like 20 source files and 4,000 lines of code. And you're like, that was your initial commit? It's like, that clearly was not your initial commit. No.
I like to just kill the .git repo or the folder and just restart after probably a couple hundred commits in.
Oh, I'm the same way. It's like, I've got the initial version and then that eventually gets to something and I'm like, okay, I'm okay with sharing this. And then delete, and just go from scratch. On one hand, I get why you do it because you don't necessarily want that bad history there. But on the other hand, it is kind of hard for somebody jumping in who actually thinks that might be the initial commit.
Yeah, seeing code evolve over time is definitely helpful when you're trying to like figure out how some feature in a code base works. I've definitely done that with like things I've been curious about, like, oh, how does this feature of like this big open source project work? Kind of just like dig through the path. So it's really nice when like the whole history is there. But I think there's kind of like an engineer kind of ego a little bit that's like, I don't want people to see like my very early on work where I made like all of the stupid mistakes that I made, like spent 5 commits trying to figure out like why this for loop wasn't working correctly or something.
That's a hard one too, because I think naturally everybody doesn't like to admit that they make mistakes or that they're wrong, or like you almost don't want to be seen as human. I don't know. I just feel like that's something that's hard to get over, is that fact that it's okay to be seen as somebody doing that stuff. I suspect that some people who live stream and do that sort of thing more often are better at it. I've always been bad at live streaming because I'm like, what if I make a big mistake on air and look like an idiot? And for whatever reason, that's just a mental barrier. But then I see other people like, just other people who stream, and like I've even seen people who learn to code like a new language live streaming the whole process. And I'm like,
that is bold. Yeah.
I don't know how you do that, because I would just sit there and be like, I'm going to get made fun of a lot here or something.
It's definitely been my experience in the past of like, you just kind of get used to it over time. I remember when I was working on the Go driver for MongoDB, it was like getting like the first big release out was like so agonizing. So I'm like, no, it has to be perfect and everything has to be golden. And then I remember there was like a really big minor release we were pushing out, and like we released it and like either a test had failed or like something didn't work and we had to like immediately release a patch for it. I was just like, oh, okay, yeah, whatever. Like mistakes happen. We can't get it perfect all the time. And it was like such a large growth for me from the beginning to like that point to be able to just be okay with that. I think a lot of people would just be like, oh my God, no, like I messed up. I'm like done forever. I'm going to go run away and hide now.
I think the other thing with like mistakes is that depending on how an organization or a company handles it can kind of shape how people address them in the future, I guess is a good way to put it. One example that comes to mind is like, we've all probably heard a story about some junior developer or somebody deleting something or breaking something, somehow breaking production, whether they delete a database file or whatever they end up deleting. And I think some organizations handle it well as a teaching experience and a learning experience of like, how can we prevent this from happening again? And others are like, he's fired, it's not going to happen again. I'm like, that doesn't prevent it from happening again. The problem's still there. So beyond the obvious, don't fire people for making a simple mistake, are there other things you've seen that work well in organizations to sort of foster that, growth through mistakes?
One thing I've seen at least is encouraging the folks who did make the mistake to build tooling to prevent it in the future, whether it's production tooling or like a CLI to help you automate the thing you messed up or whatever it may be. They get a deeper understanding of what they did and how the right way to do it is. And also, they just transmit that knowledge via code to everybody else.
I think too, like deeply analyzing like the system and processes in place that led to that, failure or mistake is super important. I think a lot of the time when we go through and we do kind of like a blameless retrospective or something, we might not pay as critical attention to like the system overall as we probably should, and figuring out like, well, what things do we not have in place that would have like prevented this, not just like on this team or for this project, but across like all of our projects.
So I think a lot of orgs tend to call them postmortems. Is that what you had in mind, or is that kind of a little bit different to you?
Yeah, I think I meant postmortem, not retrospective. It's definitely the word I was looking for.
As either one's fine. That wasn't meant to be like a terminology. Like I wasn't trying to fix or correct you there. I was just, that's the term I've heard. And I've seen like, I think GitLab has done some where like they've lost data and had like a public postmortem. I think some companies do like sort of just private ones internally, depending on the mistake and the severity of it. But I was just trying to make sure like that's what you mean and that's the kind of thing that you're referring to.
Yeah.
Okay. Yeah, I definitely agree that sitting down and having a discussion about it is useful, especially like one piece of advice I've seen is to sometimes do that without computers too, just to sit down and like, it's more about the human interactions and sort of like openly as a group, like not trying to get blame and look through the code and see who messed this up. It's more of a, how can we as humans make sure these types of mistakes don't happen again? And how can we, work through this as a, trying to be, I guess, empathetic.
And I think writing things down afterward is important too, so that when new people come along and they wonder, like, why do we do this thing like this? You can like have something to go reference. And it's like, oh, well, we had this really big outage and here you can go read about it. And like, that's why we do this in a certain way. So that's like the first thing that, I tend to do, but I think a lot of people do when they go to a new place, to start like questioning the processes and being like, well, why are we doing it this way? Is this because like we've just always done it this way? Is there like some like deeper underlying thing that caused us to do it this way?
Yeah, and I think it's all the better if the company is able to publish them publicly, because the person can get a feel for how a company deals with it before they even join.
I'll definitely say companies that do public postmortems like that, I'm far more inclined, like if I was looking for a job, I'd be far more inclined to consider them than the ones that kind of privately don't tell you what happened and you're always sitting there wondering, did the person get fired for this? Like, what happened? Especially when they're mistakes that you're like, I could have easily made that mistake. And sometimes I don't even think it matters how much experience you have.
I think kind of touch off on the outage piece. I feel like that's another side of it, is like a lot of these companies, like I've talked about this before, where like GitHub, they'll go down, everyone kind of stops work for a while. We're all freaking out, but like no one's leaving GitHub. Like it's, the cost of that outage, it's frustrating and whatnot, but if they're down for an hour, we all find ways to get around it. And sometimes those things that seem so big, those big outages, aren't usually as damaging as you might think. I mean, personally, sometimes if you're, depending on what you do, you really need to have that super high uptime, but other companies just aren't the same. So I think it's important to get some perspective on that side too.
I think the public aspect of it builds trust in the company too, as if they're willing to not only admit they made a mistake, but also give you a look inside of their infrastructure in order to tell you what happened. And at least for me, that kind of gives me a really good feeling that the company is going to be around for a while. They got a good internal culture. They're going to be able to attract good people to make it better in the future. The features are going to stick around. There's kind of a long list of things that I immediately go to when I see something like that. And almost all of the things on that list are good.
I think it's also nice to see what they're doing so it doesn't happen again. Like the best postmortems are like, here are the steps we're taking so this problem does not happen again. And then there's some that like, the biggest one that comes to mind is when we all had the credit leaks from, I don't know which company it was, so I'm not going to name any of them.
All of them probably.
All of them probably. So whichever ones it was. But like even now, I don't feel like I know what they're doing so it doesn't happen again. Like as far as I know, they were like, we're going to give you free credit checks for a year. And I'm like, well, that doesn't prevent this from happening. It just gives me a credit check for a year. So like, it'd be nice to see a list of like, here are the steps we're taking so that this won't happen to you again. And without that, it's really hard to have confidence that they're not going to have the same issue.
What's up, Gophers? Are you having trouble visualizing bottlenecks and latency in your apps and not sure where the issue is coming from or how to solve it? Well, with Datadog's end-to-end monitoring platform, you can use their customizable built-in dashboard to collect metrics and visualize the performance of your Go applications in real time. Datadog automatically correlates logs and traces at the level of individual requests, allowing you to quickly debug your Go applications. Plus, their service map automatically plots the flow of requests across your app architecture so you can understand dependencies and proactively monitor the performance of your apps. Start your free Datadog trial today to start monitoring the performance of your Go applications, and listeners of this podcast will receive a free t-shirt once you install the agent and create one dashboard. Visit datadog.com/GoTime to get started. Again, datadog.com/GoTime.
All right, so let's take a step back and look at, I guess, another mistake that somebody has made and dive into that. I don't want to call anybody out, so if anybody wants to jump in.
I already bared my soul, so.
I guess kind of a long ongoing mistake in my career is just not understanding the underlying technologies that I use, especially early on, like using like an HTTP framework, like web framework. Just assume that that's what you do. But like understanding that framework and maybe even like layers on top of that framework is a lot of times more complicated than just understanding HTTP or whatever the underlying technology is. So I feel like I've done that for a long time in my career, but more recently, just trying to step back and just understand, like, what do those frameworks actually give me? What do they add? And just a lot of times the net HTTP is, enough with a router.
So I guess first off, are you talking about going all the way down to actually understanding how like TCP works and going even below that, or?
I mean, I think it's a trade-off of like, what do you get for the abstraction that you're working with? Like, I'm not pushing bits across an Ethernet cord, but if I can, understand like, just basic headers and what they do, rather than having some other library on top of that to actually, set certain parameters. I feel like just understanding that kind of underlying HTTP, RFC, or some aspects about it helps me just to write more direct code instead of kind of, what's the word? Just like kind of candy coating on top that you don't really need. Just syntactic sugar. That's the word.
Okay. So when you're looking at that, I guess my follow-up question would be like, how do you balance that with, the taking on too much aspect of it?
Sure. I think it's definitely a trade-off. I don't know. I guess I don't know when. There's not an easy way to say, this is when you should do it. This is when you shouldn't. So I guess it's probably more trying both. And a lot of times I can work faster not using a web framework than I can using one. So I think for that aspect, it's been much better. I feel like another example would be like ORMs. Like I use those for many years of my career. And honestly, just going back to straight SQL, there's a bit of a learning curve there. But once you get past that, you just have a much more direct idea of what's going on in your code, how data is moving. You can optimize it and you can change it around. Whereas the ORM has just this whole crazy, all these little tentacles going out, trying to figure out what it's doing.
I've definitely seen both sides of that. Like back when I was working on a Rails project, it was a startup, and one of the people I was working with wasn't technical, but they knew enough to like get the code sort of running. And at one point, they started writing what was basically they were trying to use the Rails ORM to be like, you can call like user.comments or something and like look up all users' comments. So they had this like query written out, and I looked at it and it made absolutely no sense to me. And then I realized that like they just assumed all this stuff was like magically, there, that like they were just looking for stuff that wasn't there. And it kind of clicked at that point that I'm like, oh, I could definitely see somebody who's, especially somebody relatively new, not really understanding how this maps to like SQL queries and how this maps to a database table, and just being confused by what's going on. So like, I guess I see both sides of it, because I will definitely say that I've never written web applications as fast as I did with Rails and Go, but at the same time, I've never understood my application in Rails as much as I do with ones that I write in Go. And there's definitely trade-offs to that, in the sense that when you really understand things and things go wrong, I think that's where it sticks out the most.
I think it definitely comes down to a trade-off of like, where do you want to spend your time, right? Like if you just want to get something done really quick, I think then, go with the framework. But like that's going to come back and bite you later when you have some bug that's in that underlying thing. And if you don't understand how that works, it's going to be a lot more frustrating to figure out like, oh, like where is that weird thing that's happening? I've definitely encountered that like a number of times in my career, where it's just like, oh, we didn't set a timeout properly on a TCP connection. So we have like a process that's trying to write to a TCP connection for like 40 hours. And it's like, well, how do you figure that out? How do you find that out if you like don't know how the underlying stuff works?
Yeah.
I think that's part of why I'm so hesitant to try new technology. Like I have not used Kubernetes like pretty much at all. And part of that is because I'm going to push something into production, it's going to break, and I'm not going to have a clue what's going wrong. And that's slightly terrifying to me, especially when we're talking about something in production where you really don't want that happening.
Everything seems to be trickling down from big companies. And I feel like, I've worked in moderately large companies. I've worked in tiny companies. And just the approaches you need for both are just so different. that, I mean, every time I've used Kubernetes, it just seems like one crazy layer of complexity on top of another. And I don't ever feel like I'm like writing software. I just feel like I'm debugging software. So it's frustrating.
I feel like you can kind of feel it when there's such a big barrier to getting something up, whether it's Kubernetes or something else. There's just this point where you feel like, okay, I wrote this app, it's X number of lines long, and it took me a month. And now I'm taking Kubernetes as example. Now I'm writing like 500 lines of YAML, and for each line, I have to go back to docs and like look something up. If you're an indie developer or you're a small team, you kind of get that feeling that, hey, this isn't something we're ready for yet. It's a signal that, like you said, John, like something's going to break in production. We're going to have no idea how to fix it, and we're going to be under the gun. And that's just like, that's a feeling I think that people develop over time as developers, especially when they push stuff to production and get those battle scars.
Yeah, I think the point around like different size companies needing different things, I think that's like really important. And I think a lot of companies, like small companies, dive into Kubernetes because they're like, oh, well, Google needs this thing, so like clearly I need it. And it's like, well, you probably need like a VM that you know is going to keep running and you'll be fine. And if you have like 40 minutes of downtime, it's going to be okay. And you can make that trade-off instead of like this huge complexity that comes with something like Kubernetes.
I think that's a general mistake that so many people make, is wanting to use these complex technologies. And some of it is just genuine interest, which is fine. Like, I completely understand that. If you really just want to learn something, then by all means, like, you should go learn it. But I think sometimes trying to push it into a company or an organization is not the best way to learn it, because it does present those problems. And I've just seen countless examples where you get that added complexity that you don't really need to be there, and then you're just left with something that's really hard to maintain.
I find it crazy. We have, like with Moore's Law, we've just expanded computing power just, at a crazy rate, but somehow I feel like our applications are slower because we just keep adding all these little bits of cruft here and there, and yeah, it just makes me sad.
Yeah, I mean, GraphQL is one that I see a lot of people pushing towards, and I guess for me, I completely understand why Facebook came up with it. There are times where I just don't understand it for, like, if you're writing an API and you have like literally one web client that's utilizing it, I'm like, just make it return the data you need. You don't need a query language for that. Just return what you need. Whereas, like the Facebook use case is tons of different versions of mobile apps, and people are in different places where bandwidth is limited, and there's all these different factors that come into play. And I'm like, yeah, completely makes sense there. But I do think it's a mistake to try to let others sort of dictate what technology we should be using, or to like just mimic what other people are doing. And I see that all across tech, whether it's databases or, all these different things that they use. And I think that's a big mistake. It's almost like it doesn't matter if you tell somebody not to do it. You almost have to let them make that mistake.
Yeah, we love shiny things as engineers. It's so hard to really strip down to what you need in the practical sense and separate that from, what do I want to learn? What's the newest thing that I want to put on my resume or something like that?
It's especially hard with small teams because you're usually so busy that the only way to learn something is to do it on a work project. So then it gets there, and then if you're doing it for your resume, that means you're probably looking to leave, and that makes it even worse.
Yeah.
I think too, there's this, sometimes we do things as like a hack to make things look better. Like, I think a good example of this is clean URLs, which came around in the PHP time. And you're like, oh, I just want it to be like /user/123, and then like make URLs hackable. And then like, that's really cool and really fun. And I think like that just got translated into our APIs. So we started like building these complex web frameworks that could like pull wildcards out of the URL. But like HTTP comes with like query parameters, which essentially do the same thing. You actually like have a nice name, but it's like super popular across, I think, most of the industry to just use clean URLs with APIs. And I always find that like so confusing. So it's like, why do you care if your APIs are a little bit uglier if you have like a $user equals 1234 instead of just having it like in the URL, like in the main path itself? And I think we do that with like a lot of things. where it's just like, oh, well, someone did that because like there was this specific use case where it made sense and it was a good user experience enhancement, but it might not apply to other places. We just kind of like pick it up and like try and put it everywhere else.
Like one example I've seen of that where it's useful is I was actually looking at the source code for Pace with Matt Ryer, and they have URLs where they try to stick basically like the name of the task is in the URL. So if you copy paste it somewhere, somebody can actually see like this is like just glancing at the URL, they can tell what it pertains to, but they don't actually use that part of the URL. It's just like a slug that you can change to anything. And there's another part of the URL that actually has the ID, and that's what matters. And like doing it for cases like that completely makes sense if you're just trying to make it, more visibility for something. And I think Medium's a good example of this too, where most blog posts have like a slash, the title of the blog post, and then at the end of that like title, there's like a slug that they actually use.
Mm-hmm.
So like in those cases, I'm like, okay, cool, you're making this more readable. But then there's others, like you said, that are slash user slash 3 slash comment slash 456, and you're like, that doesn't really tell me much aside from I'm looking at like maybe this user's comment, but it's not really helpful.
Yeah. I think too that there's that key difference of like, is this a URL that someone's going to like copy and paste, or is this a URL that's just like two machines are going to send between each other? So I think in the latter case, like, does it really matter what your URLs look like if like they're just machines sending them between each other?
Have you guys seen, it's like a JSON API spec where you have like a self-documenting API that sort of defines the URLs for additional resources? I forget what it's called.
Oh, like hypermedia APIs or?
I know what you're talking about. I can't think of the name.
There was something for APIs where like if you looked up a user, it might like give you a bunch of links to like, here's the path to like look up this user's comments or something. Like, it was supposed to be like a fully self-documenting way to design your API. But what never made sense to me is I was like, who uses an API and doesn't understand what the endpoints are that they're going to start like scouring it this way? I'm like, I'm not writing code that's like, tell me what I can get and I'm going to magically decide. So like some of the use cases there just didn't fully make sense. That's kind of what what you said made me think of that for some reason.
Yeah. I think that's like the general idea behind hypermedia APIs, which I spent a lot of years studying hypermedia APIs, and like I think I'm a pretty big proponent of them as well. I think that first confusion of like, well, I should know what all my URLs are. And I think that the main reason behind wanting to differentiate those two things comes down to like semantic versus like runtime, I guess, right? Like we often tie those two things together, and that makes it like APIs pretty brittle. Like if you want to have a new version of your API, now you're like shoving V2 and stuff all throughout your URLs because you can't use the same name to mean a different thing. So I think like that's partly where that stuff comes from, but I also think like it's very poorly explained to people, especially when you first come into a hypermedia API or something like that, like a new concept, and people just like, it's that curse of mastery where you just assume that everybody has acquire this knowledge that you have. So it's like, oh, I understand the difference between like, a target URL is and what a semantic name for that URL is. So everybody must understand these things. And I just think too, there's not, in some ways we haven't pushed it enough as like, I guess a sub community of the industry, right? Like hypermedia is like a thing that we openly accept when it comes to browsers, but with our APIs, it's like not as much. Like we'd all probably pretty mad if like Facebook decided to update some URL somewhere and Chrome was just like, oh no, that's not what I have recorded in my source code, so you can't use Facebook anymore. Like we'd all be like, no, that's not how it works. But I think like making that translation from how something works in a browser to how something works in our APIs is like difficult.
I will say something, John, as well. You're saying like you should know the API does. This is a little bit of a tangent, but just documentation in general, I feel like is a regret I've had in the past of just like not doing enough. And that projects that I've actually done really good documentation, like Bolt, for example, I did a lot of documentation on it. I feel like that was the main selling point for a lot of people. It's just like, oh, wow, this looks like a legit project, not just like 3 lines in a README. So I think that's another regret to put on there.
I think that's one a lot of companies have or should have. Like I see so many API companies, then you go read their docs and you're like, I don't know how this works. And it's frustrating. And then you look at something like Stripe, and generally speaking, Stripe is one of the better ones. And like not to bash on them, but like there are definitely cases where I'm like, this could have been better. And they're still like the gold standard because so many other APIs, it's just like, here's a list of endpoints and that's about all you're getting. And I'm like, that doesn't really tell me what the general process looks like at all.
I think you can tell like at what stage of the development process they wrote the docs just based on reading them. Because, when you see incomplete stuff, I would guess they were trying to rush it out the door to meet a deadline. And they may understand everything in their head, they being the development team or the PMs or whoever. But sometimes it's hard to get such a complex topic down to size into that paragraph or whatever it may be. And I would go with, write the docs first. And that just feels like it takes a lot longer. So I think that may be why you see some of those docs that are just, what does this mean? Kind of, that's everyone's reaction to them.
I guess the companies also make the mistake of, like, they make the API or something like that purely for like the publicity or the like just to claim they have one. And you can kind of tell whether it's a first-class citizen and they're like all the things they offer versus, oh, it's here, but we don't really care about it.
Yeah, I think that's a good skill for engineers to have too, is to know, is this a real thing that's going to last? Or, like you said, is this just off to the side and they're going to ditch it the minute they can?
Yeah, I think it requires empathy too, just to put yourself in someone else's shoes that doesn't understand the stuff. I think it's a good exercise.
Changelog News is the best way to keep up with the ever-changing world of software. We track, log, and contextualize the coolest projects, the best practices, and the biggest stories each and every week. Make changelog.com your daily destination, or hit the snooze button and subscribe to our weekly newsletter that hits inboxes on Sunday mornings. Join more than 15,000 enthusiastic readers. It'll cost you exactly $0, and you can subscribe right now at changelog.com/weekly.
So somebody in chat's asking about mistakes in testing. Specifically, theirs was using time.sleep in tests. So they said, thanks for the clock package, Ben.
You're welcome.
Do you have any other like examples of times that you made mistakes with tests or what you've learned from them?
I could start table tests. I used to do those a lot, and I hate them now. So I find they are way more complex than they should be, especially with you do subtests now. I think that clears up a lot of the needs of table tests. And like table tests could just be a function and just do a bunch of them. So that's my rant on table tests.
I guess for like, I would have to see what you mean, I think. Because I've definitely seen table tests where just having a couple types and that's all that's in the table is very hard, especially because like once you set a type up, you almost need to like dynamically get something from it for like what you expect in the result. And that makes that type of table test tricky, I guess. Does that make sense?
No, but
like I guess I'm thinking of a case. Let's say I'm testing a database implementation or some sort of store implementation. If I create a user, well, part of my verification that it worked might be to check that the ID was set to something, and then we update it later and like make sure some other fields are checked. But like I don't know what the user's ID is going to be. Early on, I kind of almost need to be like I need results from some steps to sort of move on to the next steps and figure out what makes sense. And sometimes that's hard with table tests. I still feel like that's a terrible example.
I mean, there are sometimes like for very simple pieces of code, I'll use a table test for. I could see using a table test if you had multiple implementations you needed to test. But I would say those are probably the two use cases where I'd use it.
Are you writing more unit tests or are you writing more like integration, or what would you say the classification is there?
Yeah, it's a good question. I definitely write a lot of unit tests. I try not to write unit tests for things that are like too simple, I guess. But it's so much easier to iterate when you have something very low level. But yeah, integration tests are definitely important. So I'd say that's a good question now that I think about it. I would say I have transitioned more to integration. Just like if you can test a bunch of things at once, I guess it depends on the complexity of your app too. I don't have a great answer for you, honestly. It really depends. Just more tests are good.
I had asked because a mistake I've made is when you're writing unit tests for a relatively small piece of code, that's when I feel like table tests are very easy because it's just like an input output, like it's kind of all you need. And when you write a bunch of table tests, it feels like you're being really productive, but you really might not be. Like, because you're writing code, you feel like you're doing something productive, but you might not actually be testing things that are that important. Like if you have a package that split strings on spaces or something, like, do you really need 50 different test cases when like a couple might give you enough confidence just to move on and do other work?
Okay.
So I guess I was kind of wondering if it was like a case where when you moved more to integration testing, maybe you just didn't see it as much, or what it was.
Yeah, I mean, I think integration tests definitely give you a more real world kind of test. Actually, one thing I will say I do a lot more recently is more kind of a quick check test. There was a quick, like testing/quick in the standard library. So quick check tests, if you don't know what they are, is just basically randomized testing. And there's really fancy quick check stuff in other languages, but not in Go. You're basically just like handing off a kind of rand, like a math rand, to a test and then generating tests from that. I find that to be one of the best ways, especially for libraries where they're more self-contained, to actually go through all kinds of different iterations you wouldn't expect. I did an implementation of immutable sets, or like immutable collections, where I'd actually make I had the immutable collection, so immutable collections, if you don't know what they are, is whenever you make a change to the collection, you make a new copy of that collection. And it doesn't make a whole giant copy, it just gives you a new copy with a little bit of a change. So I did the tests. There's a quick check kind of test where it would basically randomly insert, delete, change around the collection, but I'd also do it on another kind of just in-memory basic collection. And it was very inefficient in-memory one, but I knew that would work, just like a Go map, basically. So then I could test that both implementations did the same thing with random different inputs. So I find that to be super helpful.
I think it depends a lot on like the type of thing you're building, what types of tests you want to have as well. I noticed that like when I'm building more library-like things, I tend to, I think, try and test more of the granular components because I know I'm going to like mess around with them a lot and like change them a lot. But I think if you like try to do that too much with like an application or binary, you get this kind of code paralysis point where like you want to change like a function, but now since that function is so well tested, you got to change like a whole bunch of unit tests because of that. I think that's definitely one of my regrets is the way I used to write unit tests, where I just like kind of try and test and cover everything. And it was always about implementation detail instead of testing the interface. I think like in many of my more recent libraries and applications I've built, I've started to move more towards like black box testing and like really getting my interfaces correct and making sure that I can test the different code paths throughout my application with like from the outside and not needing to like finagle with like internal state or anything like that.
That one hits me really hard because even these days I find myself writing unit tests because I want to be able to tell exactly what broke if the test suite fails. And then, I end up adding something to a function or whatever. And then all the things broke. There's like 8 tests that failed or 10 tests that failed underneath the function. When in reality, like you said, I could have just, had a black box. If I needed to test the mock version of the function and throw an interface in there and then just call it a day and probably get the same amount of coverage off of that one test instead of those 8.
I think that's a mistake I've seen where we see how other people are writing tests, or like somebody will say, 80% unit test is kind of the way we go, and we'll think that's what we should be doing. When in reality, it depends so much on what you're building that you can't just go based off what others are doing. You have to sort of decide what makes the most sense for your project. And one example I saw of this, like I said, I was looking at the code for Pace when I was talking to Matt, and I think it's maybe all of their tests, but a good chunk of their tests are integration tests that like literally spin up a Firestore database and they spin up some other stuff. I think it actually spins up their server and then has it like a Go client that just actually makes web requests to it. And like that's the whole test. So like the entire thing's running and they're doing all this stuff. And I think for some people that would seem like a weird way to test it, but for them it gives them the coverage and allows them to sort of pinpoint what's working and what's not. So I'm like, if that's what works, don't let others dictate what you should be doing.
Yeah, one thing I'll say on the black box testing, I don't see a lot of developers doing this, but when you write tests, you can actually make your test package different than your regular package. If you just do an underscore test, I do that a lot, but I don't see a lot of other developers doing that. But that kind of forces you to actually stay black box testing.
See, I've seen that, and then I've also seen occasionally the export. They'll make like an export file, and then they'll like assign variables to like unexported functions so they can access them inside of the black box testing, almost defeating the purpose of it. And I'm like, I don't think you understood why we did this. But I mean, it's okay. I guess they're trying. It's just funny because I think when they do that, they're doing it because they see other people doing it and they don't fully understand the reasoning behind it.
Yeah, that makes sense.
Yeah, I feel like the word unit and unit test has also been something that's kind of gotten a little bit out of control. I think like about a month ago, I was like on this spree of watching YouTube videos of like Kent Beck and other people that like came up with like test-driven development and all these other ideas. And it's quite apparent that what they were thinking about when they talked about like unit test or test-driven development, it's not what I think a lot of us have come to associate with those terms. And I think that leads to like confusion. For me, it's definitely one of those like, how did we get here moment? Like, are we doing these things just because everybody else was doing them, not because they're like things that actually make sense for us to do? I think it's real tough to get away from that like herd mentality of using technologies or like using test methods just because everybody else is using them.
Yeah, I think that's a hard one. I see so many people that just assume you need to learn programming and do test-driven development because it's a hot term. And I don't know, for me, that was a mistake when I tried to just do purely test-driven development. It just never worked for me. So I don't know if it's just me or what. It's just I could never write tests first for everything before I wrote code. I'd sometimes have to like get a basic implementation, then I'd go write some tests that I wanted, and some of those would fail then, but I kind of needed like a basic thing to wrap my head around before I could write tests.
Just real quick, I'll share a dirty secret that I have. I've probably written a test before I wrote the code like 10 times in my career. It always seems to work out for me. But I think the reason I have to do it that way is I only know the like user experience that I want. I don't know yet the ins and outs of exactly what the implementation needs to be. I keep the user experience in mind while I build. But after I'm done building and I found all those warts and the edge cases and everything, that's when I have to go back and really think about how I'm going to test this thing. Yeah,
I feel like TDD is really a stand-in for like a certain phase of the software development or software engineering like life cycle. Not that actual term, but like when you're actually writing code and like trying to figure out like how you should build something. I think like TDD works really well for some people, but I think there's like a bunch of us that are just like, no, we like really like to think about it in our head and then just write the code that does that and then confirm what we had and like what we thought would work with test afterward. And I think that's like a completely legitimate use case that like usually you get like yelled at if like, you try to push for that. But I think it like both ways can lead to like really high quality and good code. I think it's more about the process of like actually thinking through what you're going to build before you build it or like as you're building it more than like this specific practice that you're doing.
I see that kind of a guideline. I see that elsewhere in development too. One that popped in my mind is REST API, the concept of REST APIs. I know like it's not actually, or for a long time, it wasn't actually specified anywhere, but it seemed like there was this tribal knowledge, just like there is with testing of, what's quote unquote right and what's wrong. And I definitely feel sort of that sort of pressure in both scenarios where, it's like for TDD, for example, I'm a bad person for not writing tests before I write code, right? And, I think it's hard to really realize your style of writing code before you really start, following the trends or even evaluating the trends that you hear.
Along with your style, I think everybody has a different level of tolerance for mistakes and bugs. Like earlier, we talked about deploying and needing like continuous or like a no downtime deploy. But for a lot of us, that doesn't matter. Like I could take many of the apps I'm running and I could restart them at midnight. And even if it took 10 minutes to restart, nobody would know except for me. And we have this idea that we have to do these things like that there's one way to do it almost. So like, I guess what I'm saying is like with testing, I've found that there's a lot of stuff that I just don't bother testing at least well because I'm just not too worried about it breaking. And my tolerance for that is pretty high. But I mean, a lot of that's because I'm the person who fixes it if it's broken. It's just me working on it. And most of these are projects that just aren't that important. Like if they go down, I've got to fly in my office apparently. That's what I get for opening windows in the hot summer. But you know, like if you have that tolerance, that's okay. But if you're running like a bank, maybe that's not so much the case. And I think people need to acknowledge that sometimes it's a mistake to assume you need to test everything thoroughly, and sometimes it's a mistake to overtest.
I think like kind of on that too, I think sometimes we don't really define what we mean when we like throw out numbers. Like people say, oh, we want like 99, like 4 nines of uptime or something like that. And it's like, but that's just part of the metric. Like you need more qualifiers than that. And I think that also makes it really hard to like determine when you're actually like in compliance with something, or like when, like where you can like make mistakes or where you can like ease off of kind of these high restrictions. So I think a lot of the time, no matter like how many nines someone usually says, companies usually, or people like business people tend to think of it as like, oh, 100%, like it should always be up. And I think like by not defining those tolerances more concretely, we do ourselves a disservice. So instead of saying like, oh, well, we have to have like 4 nines of uptime within like this window of time at the minimum, so you can actually like properly track it and understand if like that's what you're actually doing.
I had seen some pushback on that concept of 4 nines. It was like someone said you're allowed to be down for some number of seconds per year if you've got 4 nines of uptime. And that illustrated to me that with any complex system, you can claim uptime like pretty much whenever. You can say, you know, oh, the user service was up even though the website was down, or the database was working even though whatever else was down. So I'm really with you there that you have to really qualify what you mean in detail by 4 nines of uptime or whatever else it might be.
I've seen some, like they claim they're up, like you said, but for a subset of users, it's down. And it's like, well, what does that classify as? Or like for a subset of users, they're just timing out. And it's like, well, we're technically up. We're just taking forever to respond. I'm like, well, that's not useful. So there is like a lot there that's tricky to figure out. And like when you were saying the pushback, I think one of the ones that always was interesting to me is that if you're relying on other services that also have like 4 nines of uptime, like it does, if you just have a couple of those and if any one of those goes down, it counts as downtime for you. Well, then all of a sudden you pretty much have to be perfect. It's like, well, that's not possible.
Yeah, I think performance is a bigger metric that I don't think people focus on as much. Like it's just one of those gray ones where like it probably helps you a lot more than actual uptime. Like being down for whatever, an hour a month or something like that. That's not great. But I mean, if your website takes, 2 seconds to load, or your whatever app call, I feel like that's, your users are just going to get tired of that. That's their actual real experience for most of them.
It's also probably important to pay attention to when these things happen. Like I imagine if you're Stripe and you're down during Black Friday, even if it's only for 10 seconds, like that 10 seconds is way more important than being down for an hour on some day where, some time at 1 a.m. when very few people are shopping.
Yeah, I bank at Chase and they're down all the time. So I'm still with them.
You're a captive audience for
They can claim 100% uptime as long as somebody's in the bank during business hours, I guess. Is that how it works?
Something like that. Sure. Something like that.
Yeah, I think that in certain parts of the industry, we think that we need to have like this ridiculous uptime or like these ridiculously high kind of like experience metrics for our customers. And then you go look at like things that everybody in the world depends on. And it's like, oh no, we're just going to take our banking site offline for 4 hours while we do an upgrade. And you're like, if something that important can go do that, like, do we all really need to like be able to do seamless upgrades all of the time? Like, is it really worth the trade-offs of like, having people wake up at weird hours of the night to like accomplish some of these goals that we have if we don't really need it?
But those technologies that enable it are certainly shiny.
Yes.
Kubernetes.
They are.
That's all I had. They're shiny and they get a lot of attention and folks pick them up.
It's because it's kind of boring to talk about like SQL at this point. It's kind of, and even writing about it, despite the fact that you can help people, it's hard to justify writing because you're like, there's a million articles out there that already teach these things. And then at the same time, we've got people who look at an article and they're like, oh, that was published a year ago. It's no longer good. And it's like, that's not how all technology works.
Yeah.
I've definitely noticed that with myself, where I like look for books or something and I'm like, oh, this book was published 4 years ago. Can't have any good information in it. It's like, no, actually, knowledge does not change that fast for everything. It's just for like some specific things, Kubernetes, where it changes like very rapidly, and old information can be not as good.
I just stepped into the JavaScript world 2 weeks ago, and man, if we thought it was fast moving here, I feel like I have to know the JavaScript calendar, something like the calendar, before I can figure out what framework to use.
One of the things that's kind of interesting to me is like when I look at a Go post, usually all you need is like the minimum version of Go, because that's like when the feature was introduced. But with like JavaScript, you almost need like an exact range of like, you got to be between 16.12 and 16.16, otherwise this doesn't work.
I wrote a React Native app like 2 years ago, and there's no way, I can't even get it to run. Like I can't get it to lit up. I can't anything anymore. It's gone.
That's a hard thing to explain though, because I think people associate dates so much with that, which I write on a blog enough that I see that where they're like, you should put dates. And I'm like, what I really should do is go back and write like what version of Go I used for this and which ones it's good for, because that's really all you care about. But sadly, that's a lot of work.
One other topic I'd be curious to hear other people's opinions on. I've been debating about this. So I have a kind of new database project I'm working on, and I'm debating about open contributions on open source projects. So one other database project like SQLite, for example, or SQLite, I think it's actually SQLite, as I learned from a previous changelog podcast, they actually don't allow people to contribute code. You can file issues, you can talk to them, they have a community, but they don't actually take contributions in part because it's a lot of overhead and just like maintaining other people's code, which may be coded differently than yours, and you start mixing styles in your code base. I'm curious, and so I'm debating whether I open up contributions or not. I'm curious other people's thoughts on that.
I will definitely say that one of the biggest mistakes I made in the first like popular open source project I had was that I just accepted anything and everything without fully thinking it through. And like, even if something has tests, that doesn't necessarily mean you should accept it. So I definitely see the restrictive side of it. I think if it were me, I would probably lean towards it's okay to tell people to follow your style guide. It's okay to like maybe say, I'll accept this, but I only like want to include these things because that's all I'm comfortable maintaining. Like to basically restrict what you're willing to accept, but I would probably still accept code if somebody was willing to sort of jump through those hoops, for lack of a better way to put it. But I completely disagree with, like, if somebody has the idea that like you should accept any PR and I'm going to submit these things and you should take my feedback, I think that's kind of a bonkers viewpoint.
I definitely agree with that as well. Where it's like there's a dance you have to do around, or I guess a dance you probably should do around like which contributions you accept and like the level of effort people will put in. Because there's lots of times where people just do like a drive-by PR where they'll just be like, hey, I had this problem and I fixed it so it worked for me, so here's a PR. And it's like, well, no, like there needs to be like equal effort on both sides if we're going to like actually accept something. But I definitely think like having other contributors can be useful, especially for people that are really invested in the project and like want to help you maintain it and want to help you develop it. So I think if you do eventually or ever do want to have help building the project, I think it can be good to have contributions. But I think there probably should be a bar, especially if it's anything complex like what you're talking about, before you can actually like get your code in, right? Like show that you actually like understand how things are working and like actually want to be a part of like the contributor list, and not just someone that's just like, oh, well, there was this tiny bug that I fixed, and I don't care about your style guys. I don't care about actually understanding anything at a deep level. But I also understand the cost of like having to sit down and analyze other people's code to see if it does fit, to see if it has fixed everything that they're purporting it to fix and that doesn't break other things. So yeah, I think it's definitely probably a case-by-case basis.
I've seen some repos that just set an expectation up front that they'll take code, but they might close PRs without acknowledging it, or they might take forever and then ask for fixes a month later on a PR, and just kind of set the stage that you can try, but you're not going to guarantee that you'll get on their review right away.
Generally speaking, I would say that I think as contributors, people should try to reach out before they write code. Like Kris, when you mentioned like sort of the drive-by PRs, I think part of that is junior developer, maybe not junior, but people who don't really know any better, who are just like, I'm just trying to help. Because I know when I was like really early in my career, I had a library that did that, and I submitted a PR, and they basically said like, we're not going to take this for these reasons, and they were real nice about it. But I just didn't really get it at the time. But now I completely understand that like it probably wasn't going to help them in the long run. It would have just caused more issues. So I definitely think there's a lot to balance there. And I do agree with what you were saying, Aaron, that like reading that code is definitely hard, even though like doesn't GitHub have a feature now that you can accept a PR, or you can allow the person you're submitting a PR to modify it?
Yeah, you can do that.
I was going to say like even that would help, but you still have to read through the code and understand it. And I think that's a balance of, you almost have to communicate that if it's easier for me just to implement the fix myself, that's what I'm probably going to do. But, you know, versus like reading and understanding your code and trying to help fix it to the point that it needs to be. But I think that's hard because there are also open source projects where I forget, there's one in Go, I forget what it was. It was like an HTTP framework that essentially people claim that they just like took submissions and they rewrote or copied the code and submitted it and didn't give anybody credit for it. And people got upset with that. And I get why they got upset, but I don't know how you balance that, I guess is the best way to put it.
Yeah, I mean, I think there were a number of times when I was working on the Go driver where it was just like, oh, someone would be like, I want this feature, and they'd submit some code. And it'd be like, oh, well, actually, there's like this way we can add this interface over here, or like put in this extra flexibility that allows you to do what you want to do, and also like a whole bunch of other people to do what they want to do. So we're going to do that instead. That's definitely like a good way to go about those types of things. But that also, once again, like takes a lot of time and energy and effort. And especially when something's a side project, I think it becomes difficult to weigh those costs well.
So let me ask you this, Ben. Are you planning on getting like a community of active developers around the project?
Using it or contributing it? Contributing to it?
Contributing, I guess.
Not necessarily. I guess my experience with writing Bolt was that there were a lot of contributions that were usually small fixes, but there weren't a lot of like complex contributions. So it was almost kind of a trade-off. Like, and even if you get a complex contribution, like you got to like wrap your head around how they implemented it. And there's some of those where I like looking back, I probably would have done it a little differently to keep the same code style and whatnot. So yeah, I mean, as far as contributions, I'm still on the fence about it. I'm kind of leaning towards closed contributions, but open issues.
I guess the way I would kind of view it is if you're building something like Go, where you want more than just your core team, like you want other people actively involved in the project and continuously writing code for it, I think the upfront effort of, you know, reading their code, understanding their code, teaching them style guides and that sort of stuff makes sense. But if it's a project where that's not going to be the case, it's going to be one or two contributions and that's about it, then I think you're completely justified in saying, just give me some, you know, issues and PRs and I'll sort of prioritize and fix them myself.
Okay. Yeah. I was just curious, throwing it out there. I haven't curious how that lands in the community as far as close contributions. I haven't seen any other Go projects do that so far.
There was one. It was an implementation of, I want to say Webpack. Did the same thing as Webpack, like bundling up JavaScript. I wish I could remember what it is. I can try to dig it up later. Anyway, at the bottom of that README, it said, this is alpha software. I'm working on it, but I don't plan to take any contributions.
That's probably a challenge with GitHub in general, is that in some ways you want to share code and in other ways, like what people view as open source is kind of different. And it can't be the same thing to everybody if they all have different expectations. Like I think we even saw this in the Go community today or recently with them changing language in the internal stuff and people flipping out. And it's like, if you aren't involved in the project, I don't really see, at least me, I'm like, I don't see how your opinion is relevant.
Yeah, I think there's nice ways to say that you're not interested in other people to contribute, but you are interested in people to use it. It's just a matter of
a little finesse.
I think, yeah, that's the right word.
Like it's especially hard too, because I think people view open source as just submit code And in every successful open source project I've seen, that's not the way it actually works. You don't just submit code. You talk about an issue first.
Mm-hmm.
And then eventually, once you've sort of talked about how you're going to implement it, you can do it. But it's very rare that just submitting code is a good way to go about it. All right. So we're a little bit late, and I forgot to do the unpopular opinion segment. So I don't know if any of you guys have prepared for this, but usually we'll ask our guests for an unpopular opinion.
Unpopular opinion.
I actually think you should probably leave.
Unpopular opinion.
So does anybody have one they'd like to share?
I just did the close contribution one.
I think for any maintainer, it's not like that
No, that's
unpopular.
fair, yeah. That's
But
fair.
for anybody who's looking at open source, it might be. So
Yeah, I mean, I would say, I don't know. I feel like most new technologies are just not necessary, I guess, would be my unpopular opinion. Docker, honestly, Kubernetes, a lot of those. I feel like you can run, a stack, not the same stack, but you can run basically like what we used to run back in the 90s or whatnot, or early 2000s, where it's just like, here's a web server running, you can run a business off of that and probably be fine. I mean, obviously back up your data, but that'd be my unpopular opinion.
I think for me, an unpopular opinion I have is, I guess once your organization or the engineers in your organization reach a certain level, that you shouldn't really just take software from other companies. Like, I think gRPC is like a big one for me, where it's just like, once you have a group of people that understands how to build things with TCP and HTTP, you could probably just build it yourself, and you should do that, because your organization's needs are going to be very different than what Google needed for when they built gRPC. So I think it's I fall closer to that, what used to be called not invented here syndrome. And I think that's probably where we should be edging back to. But I realize that is wildly unpopular with a lot of people. And they usually say, just use whatever is out there because that's better.
Well, I mentioned REST APIs earlier. I don't think they're good. That's my unpopular opinion. I think they cause more confusion than problems they solve. I do think URLs and HTTP methods are good, but the pattern of having specific rules for specific types of requests, and we also mentioned putting things in the right place in URL paths, it's all well and good, but documentation can solve those problems really well, and a good SDK on top of the REST API. Well, the API, maybe not REST API. Documentation and good SDKs can really solve those problems a lot better than some magical document or tribal knowledge floating around somewhere.
I would definitely agree that the best APIs are the ones that you don't know if they're running JSON. By JSON, I mean a REST API, which is JSON responses, GraphQL, XML, or whatever. If their library is good enough that you don't need to concern yourself with that stuff, that's almost always the best API experience.
Unless they don't have an SDK for your language, then.
And then you're just not going to have a good time. But the best ones have all of those things now.
I think even then, if it's all post and get with query strings and post bodies, every language can do that pretty easily. And I think the hardest part in most SDKs is figuring out auth anyways. So
yeah,
probably wrestling with that more.
I agree with that, yeah.
Yeah.
I guess on that REST API thing too, it feels like we lost the spirit of hypermedia and REST, and just kind of started looking at these strict rules that everybody kind of laid out. I think that's what causes a lot of the pain.
I think what makes it hard for me is that I don't truly know exactly what a strict, by the definition, REST API is. But I think the idea of sort of separating things by resources can be useful, but I definitely think there's times where it's not. One example is when I was building the backend so I have Go courses, and every course has sections and sections, or basically chapters, and chapters have individual subchapters or lessons or whatever you want to call them. If you're looking at them as strict resources, it'd be okay, you have a book, or a course would just return the course, and then you have to call an API endpoint to get all the sections, and another one to get all the lessons, and separating resources that way didn't make sense from a REST API standpoint. But at the end of the day, what really made more sense is 4 endpoints that just return the data I need for different pages. And to me, that made a lot more sense because it's what I needed. But I could see if you get caught up in this, you have to follow REST, do exactly what it says. That would be kind of rough.
Feels like we do that a lot in our industry, whether it's like agile or TDD or whatever it is. There's like this really good ethos that's just like, hey, we're just going to help you like make something. And then like people just like put a bunch of rules around it. And then if you don't follow those rules, it's like, you're doing it bad.
I feel like a lot of that stems from this desire to make things generic enough that it can work for anything. And that's usually not useful. Because I think we do that with even like databases where like we got to make the interface we interact with this generic enough that it works for everything. And then at the end of the day, you're like, why are these queries so slow? It's like, well, it's because of the way you wrote this. Like, it's not possible to actually like realize that you need to do a bunch of joins and do them properly.
Yeah, I think to kind of go back to something Ben said earlier about like, learning the underlying technologies, I think sometimes we try to create all of these interfaces and these nice facades that like really kind of mix a bunch of layers together and create these very complex things we have to deal with, when it'd be much simpler if we just kind of properly layered everything and just had very simple layers that we interacted with.
All right. Thank you, Kris, Aaron, Ben, for joining me today. This has been a good episode of Go Time. If anybody else has comments or anything like that, feel free to reach out in the Go Time FM Slack.
Cool. Thanks for having us.
Yeah, thanks for having me.
Thanks a lot.
That's our show. Thanks for listening. Do you have regrets? Ever make a technical mistake that someone else could learn from? We would love to hear about it in the comments. Visit changelog.com/gotime/135 to start the discussion, or simply open your show notes, click discuss on Changelog News, and let your voice be heard. Special thanks to our guests, Aaron Schlesinger, Ben Johnson, and Kris Brandow for joining John for this awesome conversation. You can connect with each of them online. Once again, links in your show notes. Do you enjoy our beats? We get them farm fresh from the one and only Breakmaster Cylinder. And we're brought to you by awesome people at companies who get it. Thanks to Fastly, thanks to Linode, and thanks to Rollbar. If you like Go Time, please tell a friend. We truly appreciate it. That's all for now. Go in production next week.